Here we're going to talk about the angle bisector theorem. So an angle bisector, a bisector is something that cuts something into two equal sections. So I want some kind of line, in this case it's going to be this red line here, that cuts an angle into two equal pieces. So that red line is going to cut this large angle here, that complete top angle of the big triangle. The angle bisector, the line down the center, is going to cut that red angle into two equal parts. So now I'm going to be left with these two equal parts here, these two white angles that I wrote in right here. So kind of the left side of the angle is equivalent to the right side of the angle. So perhaps for an example, maybe if this full angle was 60 degrees, then the angle bisector, that line down the center, would cut it into two equal parts. Each of those white angles would be 30 and 30. And if the big red angle was, say, 80 degrees, then those two parts would be 40 and 40. So the angle bisector is going to cut them into two parts. And now let's go ahead and talk about what this angle bisector theorem actually says. And the angle bisector theorem is going to say that the triangle is cut up proportionally. And one way to kind of write this out mathematically is to say that the side opposite an angle, so A, divided by the side adjacent. Adjacent is kind of a fancy way to say next to. So the opposite A divided by the adjacent B is equal to the opposite on the other side, so C, divided by the adjacent D. So one more time, essentially the angle bisector theorem says, starting from the angles that were sliced equally in half, start with one of them, either one, doesn't matter. And we're going to state that the opposite A divided by the adjacent B, opposite divided by adjacent, is equal to the other side's opposite C divided by adjacent D. So opposite divided by adjacent. So let's try this out on a couple of examples. So we have an example on the left. Let's go ahead and start with this one. And so the angle bisector theorem says, okay, we'll find out where the angle is divided into two equal parts. And so that's denoted here with those rings. And since I have one ring on each, that means that they are equal. So the angle bisector theorem says that the opposite divided by adjacent, so 4 divided by 12 will equal to the other side's opposite divided by adjacent, so 3 divided by x. And once we have this proportion set up, we can go ahead and just cross multiply. So I can go 4 times x, which is 4x, that's equal to 3 times 12, which is going to be 36. And then I'm just going to solve for x, so I'm going to divide by 4 and divide by 4, and now I am there, and I have that my solution is x is equal to 9. Okay, let's go ahead and try this with one more example here on the right. So again, I have my angle bisector, and technically the angle bisector itself is this line that's right down the center. So that angle bisector divides up the top angle into two congruent angles, those white angles right here and right here. So now, using the angle bisector theorem, I can set up a proportion that says that the opposite divided by the adjacent, so that would be 4 divided by 8, is equal to the other side's opposite divided by adjacent, so that's going to be x over 10. And from here I can cross multiply. I tend to just like my x's on the left side. And since we can choose what we cross multiply first, I'm just going to go ahead and choose to go 8 times x so that I have my x on the left. So I'm going to go 8x on the left, and then on the right side it's going to be 4 times 10. So that's 40. Okay, just about there. Divide by 8, divide by 8. And we have our solution that x is equal to 5. And just one last example here. Maybe we'll just set this one up to keep it brief. But I just wanted to show you that we won't necessarily always have x, of course, as a variable, and it won't always be in the same orientation. So it could be flipped around in any orientation, but I'm going to recognize where to start by finding out where I have the congruent angles. So there I have my congruent angles. I know that technically my angle bisector is that line kind of splitting the triangle into two pieces. And so now that I have those two congruent angles, I'm going to use the angle bisector theorem, which says to start from one congruent angle and write the opposite divided by the adjacent. So I could say that y divided by 12 is equal to the other side's opposite divided by adjacent. So that would be 5 divided by 20. So I just wanted to show you that we're always starting from these congruent angles here when I say opposite divided by adjacent and opposite divided by adjacent. Doesn't matter what orientation the triangle is in. And then, from here we could go continue forth and cross multiply, divide, and get my solution.